Two particles, separated by millions of light years. Measure one. The other responds instantly, faster than light. Einstein called it impossible. He said information can't travel faster than light. He was wrong. Quantum entanglement is real, and it proves space isn't what we think. In the next 8 minutes, you'll understand how particles communicate across impossible distances, what Einstein got wrong, and why this means reality is non-local, connected at a level deeper than space itself. This isn't theory. This is proven, confirmed, Nobel Prize-winning science. Let's start with the problem. Einstein spent his life defending relativity. The speed of light is absolute. Nothing goes faster. Information can't propagate faster than light. This was the foundation of his work. Then quantum mechanics said otherwise. Entanglement. When two particles interact, their quantum states link together. Measure one particle's spin, you instantly know the other's spin, no matter how far apart they are. 1,000,000 light years? Doesn't matter. The correlation is instant. Einstein hated this. He wrote a paper in 1935 with Podolsky and Rosen. The EPR paradox. They argued this proves quantum mechanics is incomplete. There must be hidden variables. Information predetermined at the moment of interaction. Not transmitted faster than light, just revealed, like opening two boxes. You find a red ball in one. You instantly know the other has a blue ball. Not because information traveled, because it was determined from the start. Makes sense, logical, preserves locality, but quantum mechanics says no. The particles don't have definite states until you measure one of them. They're in superposition. Both spin up and spin down simultaneously. The moment you measure one, both collapse. Both choose their states. At the same instant, this is what Einstein called spooky action at a distance. He didn't believe it, thought it was absurd. But he was wrong. In 1964, physicist John Bell created a theorem, a way to test whether hidden variables exist, or if entanglement is real. Bell's theorem showed that if hidden variables exist, certain correlations would have limits, mathematical boundaries. But if entanglement is real, those correlations would violate Bell's inequality, exceed the boundaries. Experiments were done, thousands of them, over decades, in labs around the world, using photons, electrons, atoms. The result? Bell's inequality is violated, consistently, dramatically. Entanglement is real. There are no hidden variables. The particles genuinely don't have defined states until measurement. And when you measure one, the other responds, instantly. In 2022, the Nobel Prize in Physics went to Alain Aspect, John Clauser, and Anton Zeilinger for proving entanglement beyond doubt. Closing every loophole. This is settled science. So how does it work? The short answer, we don't know. The particles don't send signals. Information doesn't travel between them. You can't use entanglement to communicate faster than light, because the measurement results are random. You measure particle A, you get spin up or spin down. Random. You can't control it. Particle B has the opposite spin, but that's also random from B's perspective. To confirm the correlation, you need to compare notes, and that comparison travels at light speed or slower. Phone call, radio signal, conventional communication, so no faster than light messaging. But the correlation itself is instant. Measure A and B's state is decided. Right then, across any distance. This is non-locality. The quantum state isn't localized in space, it's a global property. The two particles, no matter how far apart, share a single state. They're not separate. They're connected, not through space, through something deeper. John Bell himself said it. The quantum world is not built out of things in space. It's built out of correlations. Space doesn't separate entangled particles. Distance is irrelevant. They're part of a unified whole. And this raises a terrifying question. If space doesn't separate entangled particles, is space real or is space emergent? A byproduct of deeper quantum connections. Some physicists think space-time itself emerges from entanglement. That space is woven from quantum correlations, break entanglement and space tears. This is ER equals EPR, a conjecture linking Einstein-Rosen bridges wormholes with entanglement, proposed by Juan Maldacena and Leonard Susskind, still theoretical, but suggestive. What does this mean practically? Quantum computing. Entanglement allows qubits to correlate, process information in parallel across superposition, exponentially faster than classical computers for certain tasks. Quantum cryptography. Entanglement enables unbreakable encryption. Any eavesdropping breaks the entanglement. You'd know instantly. Quantum teleportation, not Star Trek, but teleporting quantum states. You can transfer the exact state of particle A to particle B using entanglement. The original state is destroyed. The new one is created at B. Information moved without traveling through space. These technologies exist in labs, being developed based on entanglement. On this spooky instant connection Einstein denied. And here's the strangest part. Entanglement doesn't just link two particles. It can link many. Entire systems. In principle, every particle that has ever interacted in the history of the universe could still be entangled. A vast web of correlations, connecting everything. The universe is a single quantum state, indivisible, you and I, made of particles that were once in the same place at the Big Bang. Are we entangled? At some level, maybe. The boundaries between objects, between you and the rest of the universe, might be illusions. Useful fictions, but not fundamental. Let's recap. Two entangled particles share a quantum state. Measure one and the other responds instantly. Einstein called it impossible. Said there must be hidden variables. John Bell created a test. Experiments proved Einstein wrong. Entanglement is real. No hidden variables. The Nobel Prize 2022 confirmed it. Entanglement proves non-locality. Space doesn't separate quantum states. Particles stay connected across any distance. This enables quantum computing, cryptography, and teleportation, and suggests space itself might emerge from quantum entanglement. If instant communication across the universe broke your mind, you're going to love what's next. In video 7, we're exploring string theory, the theory that says you're made of vibrating strings. It's beautiful, elegant, and probably wrong. That video drops in 2 days. Hit subscribe so you don't miss it, and tell me in the comments. What shocks you most? That entanglement is instant, that Einstein was wrong, that space might not be real. Let's discuss. This is Veritas Labs, where truth is tested.